In the previous videos, we were using standard form with large numbers. We didn't really look at why standard form is useful. Why do we bother with it? Well, it's a really good way of writing very, very large or very, very small numbers and making sense of those numbers. For example, we saw in the previous videos that you can write a very large number like 480 billion as something much more simple. 4.8 times 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 4.8 times 10 to the power of 11. And what's really good about these is often when you're dealing with really big numbers, we don't really care what this part is. We just care about this. 10 to the power of 11 gives you an indication of how many digits the number is going to have. So in this case, when you see 10 to the power of 11, you know that we're dealing with hundreds of billions. And scientists do deal with big numbers like this in all kinds of situations. For example, if you imagine a scientist who is looking at stars and galaxies very, very far away, those distances involve very, very large numbers. And writing out something like this, 480 billion in ordinary numbers, is a pain to do. But in standard form, it's much more convenient. Standard form is not just useful for very large numbers like this, it's also useful for very, very, very tiny numbers. Imagine how many millimeters across an atom is, for example. Let's say we've got a number like 0.000000259. This is a pain to write, but we can write that in standard form, and this turns out to be 2.59 times 10 to the power of -8. Now, if you don't know how I did this, don't worry. That's actually what we're going to cover in the next video, converting from an ordinary number into standard form. What we're going to do in this video is look at how to convert from a number in standard form that involves a negative index into an ordinary number. So here are the questions. We've got numbers in standard form. Remember, numbers in standard form have a multiplier like this. That has to be at least 1, but it also has to be less than 10. And they're all multiplied by 10 to a particular power. Now in this video, they're all negative. For example, here we have 10 to the power of -1. Here we've got 10 to the power of -4. Here we've got 10 to the power of -3, and so on. Before continuing with this video, you should also be comfortable with your negative indices. In particular, you need to be comfortable with the idea that 10 to the power of -1 is the same as 1 over 10, which is the same as 0.1. Similarly, you should be comfortable with the idea that 10 to the power of -2 is 1 over 100, so 100th, which I can write as 0.01. And 10 to the power of -3 is 1,000th, which is the same as 0.001, and so on. If you're not sure about any of this, you need to go back to topic N9a and recap there. Let's take a look at question A. We've got 2 times 10 to the power of -1. We can write that as 2 times 0.1. Remember, 10 to the power of -1 is 0.1. And this gives us 0.2. So 2 times 10 to the power of -1 is 0.2. Pause the video and have a go at questions B and C. Here are the answers. 7 times 10 to the power of -2 is 7 multiplied by 0.01. That's 10 to the power of -2. So 0.01, and that is 0.07. 8 times 10 to the -3 is 8 times 0.001, and that would give you 0.008. Before we move on to question D, let's make an observation about what's going on. In question A, notice we had 2 in the units column and we were multiplying by 10 to the power of -1. And if you look at what happened, the 2 moved 1 place to the right from the units column to there. In question B, we have 7 in the units column and that's multiplied by 10 to the power of -2. And if you think about the 7 starting off in the units column, it ended up moving 2 place value columns along to there. So multiplying by 10 to the power of -2 moves everything 2 place value columns to the right. In C, we have 8 in the units column, but then we multiply it by 10 to the power of -3. And if you think of 8 starting in the units column, look at where it's ended up. 1, 2, 3 place value columns to the right. So starting from the units, 1, 2, 3. So these indices give you an idea of how many place value columns you move your digits along. When they are negative, like in all of these questions, we're moving to the right. And like in the previous videos, when they are positive, you are moving to the left. So can that help us with question D? 2.7 times 10 to the power of -1 is the same as 2.7 times 0.1. Remember, 10 to the power of -1 is this thing here. But all we're really doing when we do this is move everything 1 place value column to the right. So the 2 is going to go from the units column into the tenths column, and the 7 is also going to get shifted along. So we're going to end up with 0.27, and we can't leave it like that. We need a placeholder 0 in there. Now, ideally, we can leave out this middle step. We can just think to ourselves, right, 2.7 times 10 to the power of -1, that -1 in there indicates that I need to just move everything 1 place value column to the right. Have a go at part E for yourself. Here is the answer. Now, if you think about what's going to happen, 10 to the power of -4 means we need to move every one of these digits 4 place value columns to the right. So the 8 is going to go not into the tenths, not into the hundredths, not into the thousandths, but the next one along. So we're actually going to end up with 0.0008, and it's not just the 8 that moves, all of the other digits have to get shifted as well. So that's 9, 4. So 8.94 times 10 to the power of -4 is 0.000894. We have just moved each of these digits 4 place value columns to the right. Pause the video and have a go at F. Here is the answer. Let's just focus on the 3. We're going to have to move it 7 place value columns to the right. So 7 place value columns to the right means we're going to need 6 zeros after the decimal point before we get to the 3. 0.00000304. Let's just check we've got that right. The 3 was in the units column and we have now moved it 1, 2, 3, 4, 5, 6, 7 places to the right. So it's in the correct place. And it's not just the 3, I've done it for all of these digits. So that 0 has moved 7 places to the right, and that 4 has moved 7 places to the right. So we have converted this number that's in standard form into an ordinary number.